Hi guys, welcome to my channel. In this video we are going to solve two questions about the static course, and we are going to learn how to draw the shear and the moment diagrams. And so before the solving question, please, if you like these videos, if you want to see more of the videos, please subscribe and share with your friends. If I did anything wrong, please comment. Okay, specify on the comments and I'm going to try to fix what I did wrong. Okay, so let's solve the question. The first, I'm going to show the free body diagram of this. Now you can see simply supported beam. So for example, this is going to be something like this. I have A here. What is that? It is a pin. So I have an AY and I have an AX. And also you can see here I have a moment at this direction as 300 Newton meter. Okay, so and I have a 300 Newton meter as a force by distributed load, so 300 multiplied 4, 1200 Newton as the point load, because I have to convert it to the point load. And I have a roller at B. This is B. I have a roller. At roller, I just have a vertical force, and this is By. And now this is a free body diagram of the shape. So let's solve the question here. I'm going to take the moment with respect to A. Okay, take the moment respect to A equal to 0 and minus 300, and also plus By multiplied 4. Look at here, this is By, and this is the whole length is 4 meter, and this 1200 Newton, it acts at the midpoint of the beam. Okay, so this is 2 meter and this is 2 meter, so and minus 1200 multiplied 2 respect to A multiplied 2 equal to 0. Okay, because look at here, we don't have any other forces. So from that equation, I'm going to obtain the By equal to 675 Newton as the shear force here. Okay, so let's calculate for the also A. So I'm going to write the total Fy equation equal to 0. So for the total Fy, 1200 minus 675 minus AY equal to 0. We don't have any other vertical forces. Look at here, just we have AY and By, and just we have a 1200 Newton as the force acts. So, and from that equation, I'm going to obtain AY equal to 525 Newton. Now I obtained AY and By, so I can draw the shear and the moment diagrams. I have the shear forces. So let's draw the shear force. Okay, shear diagram, sorry. And this is going to be the moment diagram. So for the shear diagram at A, I have a 525 Newton as the shear force. It's going to act as upper direction. Sorry, I don't need to show the way. This is for example, is the 525, and I have look at here, I have a distributed load, so it's going to decrease. It's going to decrease as triangular. Okay, so it's going to decrease as triangular, and it's going to affect as portion to portion. Okay, portion to portion. So it's going to be something like that. Now I'm going to show you. And I have a what is the force? 1200, right? So I'm going to apply as 1200, and I'm going to reach, for example, this point. Okay, so this is going to be 675. Now I obtain the shear diagram. If it is distributed load, like now you can see in the question, it's going to decrease as triangular. Okay, the shape of the shear diagram is going to be triangular. But if it is a point load, it's going to be a rectangular. But for this question, it is distributed load, and so the shape will be triangular. Now you can see for the shear diagram. And now we obtain the shear diagram, but to determine the maximum point of the moments, I need the local minimum and the maximum moments. Okay, so the local minimum and maximum distance in the shear diagram. So what is that? For example, this is x. Okay, and this is, what is the length? The length is 4, right? So 4 minus x. Okay, 4 minus x. 525 over 675, if you remember from the similarity of triangulars. So, okay, so it's going to be I'm going to divide the 525 over 675, and it's going to be equal to x over 4 minus x. From this ratio, I'm going to obtain x equal to 1.75 meter, okay? Now we obtained x, so we can determine the maximum point of the moment, okay? So I have a moment here. Look at this question. I have a moment here as 300 Newton. So I'm going to start with here as 300. This is 300, for example, Newton moment. And I'm going to increase at this amount of area. Look at here, at the shear diagram, okay? At this amount of area, the first part. So what is the first part? 525 multiplied 175. It's a triangular, so I'm going to divide it 2. And the area of this shape, it's going to be equal to 459. Okay? So I'm going to increase at this amount of area. And it's going to reach, for example, this is the point, and this is where is the distance of x. So for example, this is 1.75. Okay, so and I'm going to increase at this amount of area. This is 300, and I'm going to add 459, and it's going to be 759. Okay, now I reach this point, and then I'm going to decrease at this amount of area, because this is the upper part of the line and this is the bottom part. So this is going to be a decrease at this amount of area. Let's decrease. This is going to be actually normally if and it's going to reach to 0, because look at here, we don't have any other forces or any moments here, and the support is roller, so there is no any moment at this point. So it's going to reach to the point 0. Okay. For example, this is the point 0, and actually this is going to be parabolic, but I'm not good at drawing because you know that. Okay. And this is going to be point 0, and this is, for example, point A, this is point B. And also for this one, point A and point B. Now I guess you understand how we are going to draw the shear and the moment diagram for this question. So let's draw it for the second question. This is the second question. So for the second question, we have, now you can see we have 2 supports again, okay? With this one is the P. So if the P, we have 2 forces, AY and AX, and this is the roller, and we just have BY, okay? So at C, we don't have any forces. It's just a cantilever from the B to C. So now I'm going to draw the free body diagram of the beam. When I draw the free body diagram of the beam, it's going to be something like this. AX, AY, and for example, this is the point B, so it's going to be BY. And I have a force here, look at here, between A and B, 8 multiplied 4, it's going to be 32 kilonewton, right? So it's going to be 32 kilonewton, and it's going to be 2 meter, and it's going to be 2 meter, because it's going to act at the midpoint of this beam, okay? This is going to be equal to each other. And for this one, again, it is 8, look at here, it is 8, okay? 8 kilonewton meter. Multiply 2, it is 12. sorry, 8 multiplied to the 16 kilonewton, and this is 1 meter, and this is 1 meter. I guess now we draw the free body diagram. So let's write the equations and try to find the shear forces and also the moments. So the total moment at A equal to 0. And minus 32 multiplied 2, because 32 multiplied 2 minus 32 multiplied 2, and minus 16 multiplied, look at here, 2 and 1 is 5, okay? And we have just By, look at here, we don't have any other vertical forces, because I'm going to take the moment respect to A, so I cannot deal with Ay and Ax. So By multiplied 4, By multiplied 4 equal to 0. And By will be equal to 36 kilonewton. So let's write the total Fy equation, and we are going to obtain the Ay also. So for the total Fy equal to 0, 32 kilonewton, okay, plus 16 minus By 36 minus Ay equal to 0. And from this calculation, I'm going to obtain Ay equal to as 12 kilonewton. Now we obtain the both shears. So if I know the shears, I can draw the shear diagram. So let's draw the shear diagram. Yeah, for example, this is going to be the shear diagram, and this is going to be the moment diagram. For shear diagram, I have a 12 at A, okay? So 12 at A. Look at here, I have a 12. And I have the distributed load. So distributed load, I told you that at the previous question, if it is distributed load, it's going to decrease as triangular, okay? Triangular. So I have a 32 as from A to B, right? 32. So I'm going to decrease at the 30 dB. Sorry, at the amount of 30 dB. Sorry, 32. No, sorry. And for example, this is point B. Okay, so 32, I'm going to apply the 32, and I reached the point 20. And this is plus, this is positive, this is negative. And I have reached it to, so I have reached this point. And look at here, at By, I have a vertical force at By as a reaction force of the support is 36 kilonewton. So I'm going to apply as 36 at this point. When I apply 36 at upper direction, I'm going to reach at the point 16, okay? For example, this is point 16. And I'm going to decrease as at this amount of area, 16 kilonewton, okay? 16 kilonewton. And I'm going to reach the point 0. Okay, this is the C, this is A. And now we draw the shear diagram. So let's draw the moment diagram also. And for example, this is point B. Okay, this is point A, and this is point C. And so I'm going to increase at this amount of area. So when I increase at this amount of area, I'm going to obtain, for example, to 9. Was 12 multiplied to 1.5. Yeah, sorry, I wrote wrong. 12 multiplied to 1.5, and this is going to be the area of this shape. It's going to be over 2. It's going to be equal to 9. So I'm going to reach the point 9. This is 9, and then I'm going to decrease at this amount of area. Okay, so. When I decrease at this amount of area, I am going to reach the point 16. Okay, for example, this is the point 16. And then I'm going to increase at this amount of area. And it's going to be again parabolic. And 1 second, I'm going to try to draw better. Okay, and this is going to be a shape like that. Actually, this moments will be drawn as now you can see, and the question is solved. And if you like these videos, if you want to see more of the videos, please subscribe and share with your friends. If I did anything wrong, please comment. I'm going to try to do better. So see you for the next question.